Ever pondered why predicting the future seems so crucial in our lives? How is it that companies, economies, even weather forecasts tend to predict what's ahead? The answer quite often lies in a simple yet powerful statistical tool: linear regression. Linear regression, a term that might intimidate the uninitiated, but fear not. It's not as complex as it might sound. At its core, linear regression is a form of predictive analysis. Imagine a scatter plot of dots, each dot representing a data point. The core idea of linear regression is to draw a straight line that best fits all those points. Think of it as a best fit line, which is the basis of forecasting. This line represents the relationship between two variables, the dependent and the independent variable. The dependent variable is what you want to predict or understand, while the independent variable is what you expect will influence the dependent variable. For example, consider the relationship between the time spent studying and the marks scored in a test. Here, the marks scored would be the dependent variable, what you're trying to predict, and the time spent studying would be the independent variable, what you think will influence the marks. Output? Now, how do we find this best fit line? This is where the magic of mathematics comes in. The line is calculated using a method called least squares. This method minimizes the sum of the squares of the differences between the observed and predicted values, hence ensuring the best possible fit. But what makes a good fit? A term called R-squared comes into play here. R-squared, also known as the coefficient of determination, measures how well the regression predictions approximate the real data points. And R-squared of 100% means that all changes in the dependent variable are completely explained by changes in the independent variable. However, it's essential to remember that while linear regression is a powerful tool, it's not without its limitations. It assumes a linear relationship between variables, which isn't always the case. Outliers can significantly impact the line of best fit, and it may oversimplify the real-world relationships, which are often more complex. To sum it up, linear regression is a fundamental tool in the world of data analysis. It's a method to understand and predict relationships between variables by drawing a line of best fit through data points. It uses a mathematical method called least squares to find this best fit line and uses a measure called R-squared to determine how well the model fits the data. However, it's important to be aware of its limitations and not to over-rely on it. Sometimes the world is more complex than a straight line. But with a good understanding of linear regression, you're well equipped to start making sense of the world's data and perhaps even predict a bit of the future.